Alright everybody, this is our second video. We're going to be continuing our arithmetic sequences. We just got a couple different things planned in this video. We're going to be finding specific terms of an arithmetic sequence. So I might suggest that we need to find the 15th term or the 103rd term, and I'm going to show you exactly how we can do so. We're also going to be practicing writing our explicit and recursive definitions and using those to find the terms that we need. I'm going to show you a couple features on your graphing calculator, and we'll also be looking for what we call arithmetic means, which is finding two numbers in the sequence or multiple numbers in a sequence given sort of like bookends, and we need to fill in the middle part of the arithmetic sequence. So let's go ahead and get started on that. Alright, so our first example here has the arithmetic sequence of 5, 9, 13, and 17. And like I said, we need that things I need to know bubble, kind of those ideas that we have to have. So I have to know my first term, and I have to know my D value, which is my common difference. In this case, it's 4. So now I'm going to write my recursive and my explicit, and we're going to use it to find A14 and A sub 22. So these are the two terms that I'm interested in locating. Alright, so my recursive definition begins with A sub 1 equals 5. And then I'm going to say, well, I can find the next term by taking a given term and adding 4. So that is my recursive definition. Remember, you need both lines for it to be complete. My explicit definition is where I can find any term. And any term is found by taking the first term and adding the common difference times n minus 1. Alright, so now I have both my recursive and my explicit. Well, if I'm looking for the 14th term, in order to use the recursive, I would have to have the 13th term. And I don't have the 13th term right now. I mean, I can go back and I can keep calculating it, but that seems very repetitive. That's the recursive nature. So the explicit definition is going to help me a lot more here because I'm able to find the 14th term using the any term. So if I want to find A sub 14, it's going to equal, and you can use a capital A or a lowercase a. You'll find that kind of mixed up a little bit. I tend to write a lowercase, but I guess I typed an uppercase. So A sub 14 will equal 5 plus the common difference times 14 minus 1. Now the reason that it's minus 1 is because the first term has already been established, so I don't want 14 more, I only want 13 more common differences because it's 13 more spaces beyond the first. So the first and 13 more makes the 14th term. That might have been a little confusing. Okay. So now I'm going to go ahead and use my graphing calculator or calculator of any sort to find the 14th term. So go ahead and calculate that as 5 plus 4 times 13. Okay, give you a second. And I got 57. All right, so the next one. A sub 22 now is going to be 5 plus 4 times 22 minus 1. So in other words, 21 terms beyond the first. So 5 plus 4 times 21, this is going to be 84 plus 5 is 89. Let's try another example. Okay, this sequence, negative 3, 7, 17, 27. So let's start by writing the things we need to know. My first term is negative 3, and my common difference is 10. Okay, so be careful here so you don't get any confused. It's not 4. You want to look and make sure across everything that there is a common difference. We got 10. Okay, recursive definition says take the first term, and then if you want to find the next term, you're going to take the one you're given and add 10. My explicit definition says to find any term, you're going to take the first and you're going to add the common difference times n minus 1. All right, so let's find A sub 32. So I want to find the 32nd term. And to do that, we're going to again use the explicit because it helps us find any term. And I'm going to have negative 3 plus 10 times, this time it's 32 minus 1 because it's the 32nd term. So that leaves us with 31 times 10 minus 3 gives us 307. Okay, to find the 104th term, negative 3 plus 10 times 104 minus 1. So I have 103 times 10 minus 3 more. So that is 1027 or 1027. All right. So this time I'm given the arithmetic sequence. It's in an explicit form because I can substitute in an n to find the number of terms. So this is a simplified form. We talked about that previously. So a simplified form of the explicit. So again, I'm going to want to find a sub 12, and that's going to be 5 times 12 minus 7. So I know 5 times 12 is 60 minus 7 gives me 53. Okay, the next one, a sub 30 will equal negative 2 times 30 plus 5. So negative 60 plus 5, is negative 55. So the 30th term is negative 55. Okay, so I'm going to show you how we can do a couple things on our graphing calculators. And to do this, we're going to want to, sorry, I'm having battery troubles. All right, to use our graphing calculators, we're going to go into second stat. So you want, second stat. And you're going to be looking at, now stat is over to the right of the X button. So it's kind of by the arrows and underneath the delete. So second stat, and you want the second column, I believe, and it's the 5th one down, and it's going to say sequence. So if I'm wrong about that, please make a note. But because my calculator doesn't have batteries in it right now for some reason. So you want sequence, and what you can do is you can type in your explicit definition. So you type in the explicit definition, you can do comma, and you have to do X, and then let's say you want the 10th through the 15th term. For whatever reason, you're only concerned about what happens on the 10th to the 15th term. So you would type 10, comma 15, and you'd close your parentheses. So what you're telling the calculator to do is to use this sequence. The variable you're using is 10, or is X, which is like our N, but we don't need to put an N in the calculator, we'll put an X. And then it says start at the 10th term and go to the 15th term. Okay, now you could do this in many other ways. You could do sequence, and then you could do the explicit, and you could say X, and you want the first term through the 9th term. Okay, so this would be the first term through the 9th term. You can do that again. What if we only want one term? Okay, so if I want X, comma, and I only want the 19th term, so you would do 19, comma 19 because it says start at 19 and end at 19. So why don't you go ahead on your own? I'm not going to practice any of these with you, but go ahead and try them on your own with a previous one. You can even just try to call up a single term like from the previous screen. So call up the 104th term of that sequence and see if it's exactly the same thing we got. Okay, last thing we're going to work on here, and it's called arithmetic means. And what it is it's basically I'm giving you a starting and a stopping point in a particular sequence. So this sequence may go on forever. It may be an infinite sequence, or it may not. But I'm missing a term, and I want to find it. And the reason we're going to be able to do this using the common difference. So if we were to imagine that every time I go from term to term, I add or subtract D. So let's assume I'm adding. So I'm adding D. Then I'm really doing that I end with 22, and that's going to equal 2D plus 4, where I happen to start. So I will subtract 4, and I will divide by 2, and I get a common difference of 9. So there's my common difference. Now, to actually put that number back in means I have to add the 9 to the number, which gives me 13. And if you check, 4 plus 9 is 13, plus another 9 is 22. So let's try the second one together here. So here I'm going to have 3 common differences because it's going to take me 3 more steps to get to 12. So you can think of that D as how many steps does it take to get to the end of this particular sequence. So this would help you in many situations that we're going to work on in the future. So I end with 12 to say that's my finale, equals 3 common differences plus that starting value of -3. So I add the 3 to the other side, and I get a common difference of 5. Now I have to apply that common difference to this sequence. So I'm going to get a 2, a 7, and if I add another 5, I get the 12. Okay, there's another way to do this, and it'll be similar in the fact that you end up with the same result. I'm going to take the last one minus the first one, and I'm going to divide by the number of common differences. Well, essentially that's what you're doing, is you're adding these two together, just like that's what would have happened here in the previous example, and then you divided by the number of common differences. So my number of common differences here is 4. So I'd have 4 common differences to get me to this last point. So I end up here with 24 divided by 4, so my common difference is 6. Had we set it up as an equation, I would have had 6 equals 4 common differences minus 18. You would have added 18 to get 24, and then you would have divided by 4. It's essentially the same thing. You're more than welcome to use whichever you prefer. So now I'm going to apply this, and I have a -12, a -6, a 0, and a +6. These are called finding the arithmetic means. The means is in what was in between them. Okay, so taught you a lot of things here. A little bit more about means, a little bit about using your calculator, and we're going to be putting this all together when we're in class.